Let us start by reviewing the principles of both generators and motors. The first part of this in generators, let's imagine that we had a pair of magnetic poles. This is a north pole, this is a south pole, and there are lines of flux going from north to south in this fashion. And if I were to take a conductor, a piece of copper or aluminum conductor, and I were to move this conductor with a velocity v at right angles to the lines of flux, a very interesting thing happens. A voltage is induced in this piece of wire. It's as if this piece of wire becomes a battery, a voltage source. The value of E sub I is given by the product of the flux density, which would be a measured number of lines per square meter, multiplied by the length, the effective length of the conductor that goes into the board, times the velocity at right angles to the magnetic field, and this would be a measure of the induced voltage. Furthermore, we can find the polarity of that voltage by doing this. Let's take the drawing of the B vector, which is from north to south, going down, and the velocity is going off to the right, and we form a cross product of crossing the velocity into the flux density. And when we turn this through this 90-degree angle, we find that if we were using the right-hand screw rule, the screw would go into the board. So V cross B, done this way, means that there will be current flowing into the board, and so we show the tail end of an arrow here indicates there's current flowing this way. And if I look at it from the side, I'd be seeing a battery, basically a battery. It looks like this, where this end is what I'm seeing over here, and this part is behind the board. So it's as if I just create a battery where we can compute E is equal to B times L times V, and this gives you the polarity of the voltage. Now, if I were to move this conductor in a downward direction, in other words, I move it parallel to the lines of flux, then when I go to cross V into B, since they're both in the same axis, there'll be no voltage induced. So if I have motion along this direction, nothing's happening. If I'm going this way, I'm getting current flowing into the board. Now, if I'm moving in this direction now, let's imagine I'm going from right to left, I'll get a voltage induced with the opposite polarity, because what I've just done is I just reversed the polarity of this V vector like this. And so when I cross V into B, it's coming out from the board. So I'd show the head, or the tip of the arrow coming out this way. So if I take this conductor and just move it once around within this air gap where we have these lines of flux, you can see I can generate a positive voltage, no voltage, negative voltage, no voltage. And if I were to stretch this out to become larger like this and more circular, as I start moving in a circular path, you can see that this voltage becomes a sinusoidal voltage. Starts from 0, goes up, hits a positive value, declines, goes down to 0, comes around here, starts to go negative, goes up the other way. So this is the principle of which all generators, including DC generators, work. And although the voltage is sinusoidal, by means of a device called a commutator, we can rectify the rectify the AC and make DC out of it. Okay. Well, let this principle sit over here while we go over to this area and do a similar argument with a north pole and a south pole. Here are the lines of flux again, going from north to south. But this time, when I put the conductor here, I will not move it. I'll just let it sit there, stationary. And while it's doing that, let me put a current into this conductor from an external source. Let's say I had a battery out here someplace, and I run this in here, so the current is going in. So I'll show the tail end of an arrow. The current is going in and comes out to the other end someplace. This could be a long piece of wire, comes out and does something like this. Let's put a bit of resistance, keep the current within a reasonable value. Now what happens?